Um, right, so here you can see Rupert making his way through the maze. So this is what we're going to kind of build on today. There's a few steps. So obviously, Vineeth, you might be a little bit behind here, but hopefully you can kind of catch up and it'll make sense.
Yeah, on the YouTube videos as well.
Yeah. So I'm going to kind of host a competition. I'm going to basically give you all the answers today. But if you guys can get round to building it and then perfecting it, that's where we want to be. And then you've got a little timer up here. I want to see videos of you guys with your complete timers. Quickest time, I'll hand out a prize to. I haven't thought about what it is, but there you go. Rupert's just completed the maze. So I've got it about 86 seconds. That's my average time. So yeah, just to cover some things, because I know it's been 2 weeks and attendance has dropped off, but I assume that's to do with the travel window and the exams and assignments and such. So this is mainly for you, Umar. You remember this, so you can help me out. I'm going to call on you quite a bit because you've obviously been here, you and Sahan. So you guys are going to get quizzed during this session. Sahan, were you there for session 2.5 when we did a bit of that robot stuff?
Yeah, I was there for a bit.
Okay, cool. So guys, basically Roboton.io is the virtual software that we're going to be using. It's this. All you have to type in is literally Roboton.io and get a free account, and then just choose Passport and open up your own account, right? And open this up, and then you get 3 options, and you can choose to write in JavaScript, Python, or blocks. We're doing blocks because I don't want to have to show you guys a whole new language. I don't know where your background is, so blocks is just fairly simple. Okay. So when we're considering our robot, we obviously have these sensors on Rupert here. So this is our little Rupert over here who's trying to drive away from me. Let's see if we can find him. So this is Rupert, and he has 5 sensors on him, as you can see, pointing left, right, forwards, and then in 2 45-degree angles. So I'll put Rupert down. He can make his way around. Sorry, a bit of background noise. So we have to complete that, and then we can control Rupert's speeds on his wheels. So basically, we have these blocks, which you can see here on the right-hand side, and these blocks program Rupert and tell him what to do. Okay? Yeah? So this is where we wrote what we call a state machine, and I'll cover that in just a second. Now, firstly, we did a little trial code, so we covered this in the last session where we stopped Rupert from hitting the wall in front of him. So basically, pseudocode, which is just our kind of written text of code, tells us what the code's going to do. So if our front sensor, this one here, is shorter than 5 units of distance, if there's something in front of us, we're going to set our motor speeds to 0. We're going to stop the robot. Right? Fantastic. We did the same thing. Vineeth, if I'm kind of patronizing you and this kind of makes sense to you, then you can tell me just to shoot ahead. Yeah?
Yeah. I'm currently I'm here at the UAS project.
Yeah.
Yeah. I'm the masters. I'm doing that, so I know what I'm doing.
Fantastic.
Yeah. Same.
Right. So we shot through how to get Rupert to turn around, and then basically this not being an ideal solution, because if you just tell him to turn around when the sensor goes high, he's going to just turn into the walls and it's not going to work. So we developed a state machine, okay, which is basically to remind Rupert, because the code's constantly shooting in a loop. So this little bit here, I don't know if I can zoom out. This code all happens in a loop, and while it might look daunting, it's pretty much copy and paste most of the way through. So this code constantly loops through, and this is his decision making. But every time he runs through this loop, he would just forget, my sensor went high, so I'm going to keep turning, right? So when he'd suddenly see another wall, he'd just forget that he was turning, and he'd just ignore that command and do something else, and he'd basically just glitch out. So our state machine, what it does, it essentially records a state variable every time. So we basically say, initially, our state is going forwards. We're going to tell Rupert to go forwards. If our state is set to going forward, which it is at the beginning, we're going to check for incoming walls. If there's no incoming wall, we're going to check for any gaps in the walls, things that we can turn right or left into. And then if there's no gaps, then we're just seeing a straight corridor. We're going to keep centered, and we're going to centralize ourselves down that corridor. Okay, that's the kind of 3 steps. If at any point he comes across an incoming wall, so something straight ahead of him, or some sort of gap left or right, we're going to go into his turning state. Okay. And there's a little bit in here checking for the incoming walls. We check the walls, then we check whether there's anything left or right of us to turn into. If there's not, we're going to obviously turn around. If there's a left exit, we'll take the left. If there's a right, we'll take the right. So we'll set the state of turn. Likewise, if there's any gap down a corridor, if we see a left or right entrance that we can go down, we're going to choose the appropriate state. Okay, we're going to either choose to turn left or right down that gap. Okay. If the state switches to turn, and I've symbolized it here by just turn, it could be turn left, turn right, or turn all the way around. Those are your 3 turning states, right? That's all you can really do. If it turns, if you got to your turning state, we're going to ask ourselves, are we still turning? Okay. We have to check, have we actually already been turning before, right? Are we still turning? If we're still turning, we're going to keep turning. We're going to keep doing that, and our state is still turning. And then when it checks here again, it's going to say, is the state going forward? No, we're turning. Are we still turning? Yep, continue to turn Rupert. If we are done turning, if we've turned all the way left and all the way right or all the way backwards the way we wanted to, we're going to go back to our state being straight. Okay, and then when we go through our loop again, starting from the top, the state is going to be straight, and we're going to check again for all the walls. So this is basically our checks, and this is our actual action. Okay. So it's essentially so that when we're turning, we don't check our sensors and get ourselves muddled up in what we're supposed to be doing. So we're also deciding that there are clever ways you can figure out how to turn Rupert around. Rupert is the name of the robot, by the way. There are clever ways you can do this. You can measure all the sensors until you get equal outputs and stuff. We're not going to bother with that. We're just going to time it. Okay. So we're just going to say a number of loops. While you're turning, it's going to have shot through a number of loops. Once that's completed, we're roughly at 90 degrees. Okay. So we're going to implement a counter. Okay. What we're going to call a turn counter. Okay. So this turn counter, and we went through most of this in session 2.5. This is just a light recap, so don't worry about it too much. So basically we implement a turn counter. So all it does is when we're in a state of turning, when we detect a wall or when we turn to our turn state, we reset our turn counter. Okay, we say that left is going to take 15 iterations of the loop to turn 90 degrees left. Okay, so we set our turn counter to 15. Then when we're in the state of turning, we check the counter. Are we still turning? Is this turn counter higher than 0? Yes, we're still turning. Therefore, turn Rupert and decrement our counter, right? Take off 1 loop from that counter. We're going to keep doing this until the counter is 0. Right, until we've had 15 loops through, and then we're going to stop turning Rupert and we're going to change the state to straight. Does that make sense to everyone?
Yeah.
Okay, fantastic. And then here we just kind of showed a diagram of the options that you've got. Right, we can either turn around, turn right because we're at a dead end, turn left because we're at a dead end, or turn right because there's a gap, or turn left because there's a gap. Okay, so in code form, it looks very beautifully, you're going to say, like this. Right. Can everyone see this, or is this too small?
No, that's fine.
Okay. So I want you guys to, actually, I should probably show you. Let me show you on my other one. Oh, why is it going to do this? Right, I'm going to show you on this one. So this is what we designed last time. So here we say, we check our states first. If the state is going forward or straight, right, and we've set our state to straight already, this is our outside our variable, and we've got our turn counter, yeah, so this is already set to 0 at first. If the state is set to straight, we're going to check if the front sensor is less than 5. Do we have anything in front of us? Right, I'm just going to take you through the code really arbitrarily. This isn't how I'd like to do it. Usually we'd build it together, but I kind of want to get onto new things. So if there's something in front of us, we're going to check, do we have anything to our left? Is there a gap on our left? If there is, we're going to set our turn counter to number of turns that we want, and we're going to set our state to turning left. Okay. If there was not anything to our left, perhaps there's an entrance to our right, we check the right one, again, turn the counter, reset the counter and set the state to turning right. If there wasn't anything, but we've reached a dead end, obviously, because the wall is in front of us, we're going to turn around. Okay? Everyone happy with that? Cool. If there's nothing in front of us, so this criteria isn't true, we're going to check. Maybe we're down a corridor and there's an entrance to our left. So is the left sensor suddenly really, really big? Has it gone over 15? The distance measured is over 15. If so, we're going to set our turn counter and we're going to turn left again. Otherwise, check the right side, check there's not an entrance on our right. We're going to reset the counter and we're going to turn right. Okay? So that's left and right. Now that's basically saying we've got nothing in front of us, nothing to either side, go straight down the corridor. Here we've got our little bit of code that says if the wall to my left is too close, it's closer than 5, I've maybe veered too far to the left, so I'm going to increase my left speed and I'm going to centralize myself. Otherwise, again, controversially, if the right side is too short, we're going to increase our right motor and we're going to steer ourselves back into the center of the path. If both of these criteria aren't true and we've got no sensors, we're just going to go straight. Okay? That's basically all of the sensor checks.
I think you mean conversely, not controversially.
Yeah, but just the opposite of that. Anyway, so then we've got our 3 turning states. Someone pointed out last time, and it was very clever, that turning around is just twice turning left or right. Okay, so you could plan to have choose when you're turning around just to set turning right or turning left and double it. All to each to their own. Anyway, so in our turning state, we turn right. This is what we've just implemented here. This is our turn counter to make sure that we're turning the right amount of times. Is the turn counter greater than 0, right? If the turn counter is greater than 0, so we're still turning, we're going to set our left speed and our right speed to turn ourselves on the spot. And we're going to keep the state. We're going to maintain the state as turning right. Okay, we're going to keep it going and we're going to decrement that turn counter, registering that we've had 1 turn. If the turn counter is 0 or lower, which it shouldn't ever be, set your state to straight and we go back to checking our sensors. Okay, so is that happy with everyone?
Yeah.
Okay, so did anyone actually have a go at trying this since last week? I'm not expecting so.
No, I haven't had a chance to, but
No, that's fine. That's fine. Anyway, those of you that would have, you will have reached a problem, and I kind of highlighted this at the end of, I think, session 2. Essentially, one problem we get is that Rupert will come along this corridor. Let's say he comes up here, and this sensor suddenly will become very high. Now, we've told Rupert if that sensor goes high, that there's a gap here on our right. Yay. Rupert detects that immediately, and without thinking, goes, right, turning right. He turns right on the spot, and he will turn right exactly on that spot. It's not a good demonstration when the image turns exactly perfectly. Hold on. Okay, so Rupert comes up this corridor. He spots a gap here, and immediately turns on the spot. And you will see that Rupert will knock into that wall. Okay. Does anyone have any ideas about how we can solve this without reading my next slide?
Maybe have Rupert, when he's going straight, move 1 step straight, like that. Like that. And
come up and then turn on the spot, and then kind of go through the gap.
Yeah.
Perfect. So,
as in, like, because we don't know how wide the gap would be, try and get Rupert to find the distance of the whole gap and then reverse to find the midway point and then turn right.
Oh, perfect. What? So you get him to drive up and down and then find the midpoint.
How much the gap will be each time. It could be different widths. So
in this scenario, I'll just tell you, you're right. You could come across this in a maze, but in this scenario that we've got, the maze is always a set size.
Yeah. So
that's like that.
You can just tell him to, go the half the width to find the center and then turn right.
Yeah, so you could run the motors, find the other point, backtrack half of that amount, and then you could turn around on the spot. No, I like that. So in this case, just because we have even gaps and we know what they are, we're going to go with that option that Umar suggested. One option that I did try at one point was getting him to slalom his way just directly into the gap by turning the motor speeds to the right thing. That, again, could work, but you'd have to get it just right, and we don't want to do that. Okay, so what we're going to do is we're going to get Rupert to go detect a gap and not get too excited immediately. He's going to take a little bit of time. He's going to keep his composure. He's going to move forward a bit. I'm going to call it a nudge. He's going to nudge himself forward. Then he's going to turn himself on the spot, and then he's going to move forward. Okay. Another thing that we need to note. So here we go. We detect the gap. We nudge forward a little bit, and then we turn. Okay. Now we need to note as well, when he's nudging forward, he needs to remember, in the same way that he's turning, he needs to remember that he's still in the state of moving forwards. Okay, so now we've not only got, are you turning? We've got, are you nudging forwards? Then are you turning? Okay, so we're going to have to remember that state as well. We're going to have a nudge counter or a nudge state. Okay. The other thing that we need to know is, while we've come up the corridor, we've made Rupert move forward a little bit. We've made him turn around on the spot, 90 degrees. We're happy there. If we just left Rupert to his devices at this point, anyone guess what would happen?
He would move forward, but he wouldn't know where to go after.
Yeah, so he might move forward and then get a little bit lost. Yeah. But one thing that I'm going to point out is that once he's in this position, both of his sensors on his side have suddenly gone, ooh, there's nothing to the side of us. So he's going to go, sweet, there must be a gap. I'm going to turn around 90 degrees. He's going to turn around 90 degrees. And then he's going to go, oh, there's a gap to my left. I'm going to turn into that gap. And then he's going to turn around 90 degrees. And then he's going to go, oh, my sensors. And you see the point. You see the point that we're stuck in. So then he's going to get into this nice, fun loop of just doing this over and over again, right? So we need to tell Rupert when he's finished doing his nudge, when he's finished doing his turn of 90 degrees, he needs to move forward a little bit, okay? Until we're inevitably going to reach the next wall of the maze, okay? And then at this point, he's reached the front wall. His front sensor's been triggered because it's too short, and then he can make a decision on turning left or right. Okay, so that's the approach I've taken. Feel free to model your own or try out some variances on this. I just obviously wanted to keep things uniform. So what we need to do is we need to implement a nudge forward, a timed loop, a turn, which is again another timed turn, and then nudging forward again to make sure that he goes through this gap. Okay, so if I show you, if I go back to my dashboard and I choose state. So again, this is the answer. Kind of sucks to have to show you this. I would have liked to have built this with you all, but it is what it is. So here, you'll now see that as well as turn counter, which I've just called counter in this, we've got nudge counter and post nudge counter. You can call it whatever you want, okay? So here, whenever we set him to turning left, right, or forwards, all we've done is we've added 2 extra counters. We're going to set the nudge counter, the counter, and the post nudge counter. Okay? Yeah. I've said that when he's reached a wall, he doesn't have to have a pre-nudge counter. Okay, we've only got that to go through gaps. So your nudge counter is 0. Okay, because otherwise you're going to see a wall, you're going to drive forward a little bit into the wall, and then you're going to try and turn around on the spot. So all we do is we add in these nudge counters, and then when we get to our piece of code, to our turning state, here now we have turning right. Okay, turning right, we first check our nudge counter. Okay, if our nudge counter is greater than 0, we're going to keep nudging, so we're going to go forward, right? So we're just going forwards here. Then if our nudge counter is 0, we're going to check this statement. We're going to say else if, otherwise, check your counter is greater than 0. If the counter is greater than 0, we've done the turning portion. And then we're going to check the post nudge counter. Okay, so this is going to allow us to go through the gap. And that is pretty much it. This will get you through a hefty amount of the maze with a bit of tuning on how fast you've got the motors going, how long you want to turn for, how high you set those counters. And there was only one last thing that I did, but I'll explain that in just a little bit. So this will kind of get you running around the maze, avoiding all the walls if you tune it properly. But it won't actually help you solve the maze. Okay, guys, so this is what I'm going to briefly touch on in this session. So maze solving. There are lots and lots of maze solving techniques. I was going to show you a few. Not there. Is it here? Yeah. So here you can see there's quite a few. There's some more common ones than others. The random mouse. Sorry, I've just lost all your faces. I kind of want to see you as well. The random mouse technique. Very, very simple. It basically says when you've reached a turning point, make a random decision to turn left or right, and eventually you'll basically explore the entire maze until you reach the exit. It's not a very smart way of solving it, but it will work, so you can always try it. The wall follower is the one that we're going to do, and it's a very, very common version. Okay, essentially, the wall follower. Has anyone heard of this before?
Yes, but not in this context.
Okay, so if you're ever in a maze, you can basically put your hand on one wall. So we're going to put our hands on the right wall, imagining that we're coming into the maze this way. And as long as you always keep your right hand touching a wall, you will eventually, although it's not very exact, you're going to go into a few dead ends before you figure your way out. You will eventually find the exit. Okay? It's quite a neat thing to remember if you're ever doing a little Cocoa Pops thing on the back of the packet. It wows my nephews every time. But honestly, this works. The only problem is it doesn't work in every scenario. Okay? It only works when the maze is what we call simply connected. Now, I don't pretend to know a lot about mazes. I've just Googled this now. But simply connected is where all of the walls are connected to the outside boundaries. So here you can see every single one of these walls is connected to the outside. Okay? In the possible case that there wasn't one, you would find yourself going round and round and round. And this is actually highlighted if I put Rupert onto the large maze. This one has walls that don't touch the inside, and it's been designed that way by the developer so that people can't use the wall method. Okay. Now, more complicated methods do involve machines kind of remembering paths using kind of SLAM or planning out maps. And usually if you ever go into a competition like this, your robot would have a trial run, which is kind of a cheat, where your maze solving robot would run around the maze as fast as possible, mapping out all the dead ends and everything. And it would be really, really clever. We're not going to do that. We're just going to implement the wall follower for this. Okay. So has anyone got any ideas on how we're going to actually implement this?
Would you generally just get it to turn left as much as not left, right?
Yeah, that is essentially it. No, yeah, it's not a trick question, guys. It's literally just tell your robot to turn one way. Unfortunately, that was got with a pinch of salt. Okay, so basically we just tell Rupert, ignore. If you always want to keep something on your right, only ever turn right. Okay, we're just always going to turn right. However, that's not always the case, as highlighted by this point that I reached in the small maze. Say Rupert reaches, let him just turn that corner. So that's him nudging forward, nudging out, and then turning. Removed this little slice of code. All that says is I've taken it out of here. Okay. So now we still check if there's a wall in front of us. If there's a wall in front of us, we've prioritized right. Okay, we've said if there's a right exit, take the right one. Otherwise, you can turn left if there's no other way out. Okay, and if there's no left or right, then you're going to turn around. Other than that, we've just removed the turning left statement here so that he doesn't check for any gaps on the left side of him, right? So it's really, really that simple. Okay. The other thing we've done as just a last little hack is because we've got Rupert basically deciding that if he's too close to this wall here, he turns right. And if he's too close to, oh, now I've sent him off on a little tangent. Yeah, turn around. There we go. Okay, so if he's too close to the right wall, he should turn. Oh, trust him to do this. Yeah, so basically we've got him slaloming in the middle. This is what this code does here, right? It basically says if you're too close to the left wall, speed up a little bit to get away from it. If you're too close to the right wall, speed up a little bit to get away from it, otherwise keep straight. What you'll notice is in a scenario like this, he's going to slalom around. He's going to ignore the left turn because we've told him don't listen to left turns. Okay, don't listen to a left turn. But he's going to be like, my right turn. Yeah, I'm still close to my right. I'm going to keep going forwards. Okay.
Yeah.
So he's going to keep turning with that motor speed because he's not correcting himself to go left. So he's going to keep turning into the gap, and it'll muddle you up. So all I've written here is an extra line that basically says, if your right sensor is high and is low, and your left sensor is less than 20. So if you're too close to the right wall, and your left sensor isn't really, really high, there's not a gap there that we're just missing, then you can turn. Then you can speed out of that. Otherwise, just go forwards, right? And this is all of Rupert. This gets you around the maze, okay? So one thing I'd like to see is whether you guys could implement anything more clever, perhaps speed them up because you can change the speeds of everything, and see whether you can beat my time of 6 seconds I've posted on the chat. And that is kind of it. Yeah, so I've gone over the final touches there. Just avoid that slalom. I've kind of given you a diagram here. So that's basically it. I've tried to get through that as quickly as possible, guys, because last few sessions we've gone over hugely. Next session, because I don't want to take too long, but I quite like to see who can get Rupert or whatever you want to call your robot going around faster than mine. Next session, I want to kind of move on to 3D printing, 3D modeling and stuff. So is there anything you guys would like to cover in that Fusion 360 session next week so that I can tailor it to you? I'd like to remind people that this is not what we would normally do in Brez. Normally we'd actually get you guys building these little maze solvers and 3D modeling parts for it, but obviously with COVID, we kind of have to restructure. So is there anything I can do in this virtual format that would help you guys out with your studies, or you would like to learn in Fusion 360, or that you'd like to build?
I still need to build that Switch holder for my Switch.
Okay, so we can take a look at your Switch holder problem, right? Just get that done for you.
I would like to design like a you do models and assembly models, like say like a like an aircraft bomb bay doors opening. Is that something that's possible on Fusion 360?
Yeah, so you can model things, you can combine models, you can add joints and animations, you can render things. It's fairly versatile. So yeah.
Look into something like a so on a drone, the bottom of opening to drop like a payload. So
okay.
How the mechanism of the door would open and the payload would drop. That's something I would like to look at.
All right, yeah, okay, so you want to look at opening mechanisms. So what I'll try and cover, because I'll try and keep it short, and there's obviously a lot you can do.
Yeah.
I won't touch on everything. I'll send some resources, but yeah, it's good to get an idea of what you'd like to do. Are you thinking in terms of just how to show it, or how to actually develop the mechanism that does the release?
Well, I'd like to develop the mechanism, but to show it to my group, like my idea, the whole animation itself would be quite, it would be useful. Otherwise, I could just use the individual parts. How the whole mechanism would work in tandem with the controller and stuff.
All right, so what I'll try and do is we'll develop a little model to touch on like the basics of how to build things. Then I'll introduce joints and a little bit of animation. Does that sound all right?
Sounds perfect.
Yeah. Umar, is there anything you'd like to cover in that session next week?
Perhaps maybe go through some of the basics involving building robots, because I'm also doing a robotics course, a short robotics course on the side. So maybe
cool.
that
Cool.
might be helpful.
Okay, I'm not sure how to incorporate that exactly into a 3D CAD session, but there will be some stuff coming up. We're hoping, fingers crossed, everyone, because I'm hating this whole virtual thing as much as you guys are. Fingers crossed, we'll start next term. We'll have some rocket launches going. We'll have some drone flights, and we'll have hopefully you guys being able to build some of these kits. And actually building out either your sumo bots or your own maze solvers. Does anyone have a preference to what they'd rather do there?
Rockets definitely sounds a lot cooler.
Okay, cool. If I gave you guys the option of doing a sumo bot competition or a maze solving competition, what would you rather?
Sumo bots.
Sumo bots.
I think, I mean, like, I don't know, they seem like a lot of fun to play with.
Okay, fine. Well, we'll cover that then. All right, that seems good. That's kind of a brief touch on this session. There wasn't really too much to go over. If anyone, I would really appreciate if people had a go at this, because I think you'll reach different challenges than I did. If anyone would like to have a go at this, Roboton.io is all free. Go over there and try and build this kind of state machine robot. Use the examples from the videos, and then send me your times. If you reach any trouble, message us in this Teams chat. And then next week I will plan out a 3D printing CAD session. I don't have a lot of time, so I'll see how much I can manage. Does that sound good to everyone? Sorry, this session was short, but short and sweet, right?
The session would be next week.
So I'll put out a doodle poll on the fundamentals chat just to kind of gauge everyone's availability, because I don't want to set a time and it kind of messes everyone up. Okay.
Understandable.
Yeah, because you've all got your own stuff. I've got a busy schedule, so I don't want to just annoy everyone. Okay.
Yep.
And then I guess the final check is there anything else in terms of robotics that we haven't covered in either the boot camp or the fundamental sessions that you guys still feel you would like to do?
I want to do something with the kit I bought, because I bought the kit. I bought the Elgu starter kit. I just want to see if there's any like projects I can like try doing in my own time, or if there's like
okay.
I don't know if there's anything I could do with that.
I'm sure Rob and I can send you some starter kit projects that you could get going with that as well.
Awesome.
Instructables is a good choice. Vineeth and Umar, is there anything that you guys have come to Brez or come onto this video today to kind of like learn about or find, and that we could kind of tailor your experience to, because we're having to do everything virtually? It's all weird.
One of the main, I was pointed impressed by one of my lecturers, and because this year I need to do a bit of like image processing and stuff. So I don't know if that's something in this particular or like
image processing. So we probably won't cover that in fundamentals, because this is like low level stuff. Image processing, I'm trying to think of the relevant project. You might find something useful with the medical project. Okay. But I'm not sure if they'll be covering tutorials, whether it's kind of more like learning on the go. So yeah, drop a chat maybe in the main Brez WhatsApp if you've got it, and just kind of ask about that. Yeah, cool. No further questions?
None.
Does Brez give out starter kits to students?
Yeah, this is one thing we thought about, and we started pricing them up, and they're quite expensive. So unfortunately we did. Even I
can send link.
Yeah, actually that's quite good. There are some cheap starter kits that you can get going with. But yeah, we unfortunately couldn't budget a kit for every Brez member.
Okay, cool.
Sorry about that. But yeah, Sahan can send you a link.
I'll send it in chat, and I took an L because I paid $35 for it, and then when it arrived, it went down to £26. So
yeah.
Big L.
Get it at the right point. Get it at the right time. All right, guys. Thank you for turning up. Sorry this has been short, but hopefully you guys can get cracking with your maze solvers. And we'll see you next week for 3D printing, 3D modeling.
Yeah.
Cheers, guys.
Cheers. Bye.
Bye.
Bye.